So again, we're simplifying rational expressions. This is huge. It's big in terms of trying to figure out the math that we're supposed to do. And it can be a little difficult for students to fathom, to understand. And I'll try the best I can. With that said, let's go ahead and get started. So I've got the first one, which is 1r divided by 3r. And then somebody's going to say, well, I don't see a 1. Okay, there's a 1 there. You can say AR or 1r. So here we go. If I'm dividing one term by one term, and this is one term divided by one term, I can divide it and see what divides out. The r's cancel, I'm left with 1/3. That's my answer. However, it differs when I've got one term divided by two terms. And it's very simple to understand what I mean by that. If you have a subtraction or addition between two variables or constants, it's two terms. So that plus separates it into two terms. There's no addition or subtraction there, it's a multiplication, so it's just one term. Now, I can't divide one term by two terms unless they are exactly the same. But I can't divide a one term by a one term if it's separated by multiplication right here, which it is. That's legal. I can do that. So I can't cancel out these y's. And a lot of students say, well, why can't I? Because this is all one term and this is two terms. You know, when you account for it, it has to be something like 2y. Not y plus 2, not y subtracted 2. So when I do the second one, the 5's can cancel because it's one term by one term. And I put parentheses around it for students to understand what that really means. And I've got y over y plus 2. Like I said, you can't do anything more than that. This is one term, and these are two terms. You can't divide one term by two terms or two terms by one term. You can divide one by one. You know, if this were y and there was nothing there, you could divide that. But since you got an addition or subtraction there, it doesn't work. Still, students don't get it. Then I say, okay, put an imaginary parenthesis there. See, they're not the same. This is y plus 2, this is a number plus 2, and this is a number. Doesn't work. Done. But you can always divide one term by one term. Well, if you can simplify something, if there's something in common that they have, then you can do one term divided by one term. Next example. I think we'll do this one next. Why not? What I want to do for the numerator is take out the GCF, what they both have in common. So I got 6m cubed subtracted by 12m squared. And right now, I can't do anything. I got two terms divided by one term. So that ain't going to work. But what I can do is take out what they both have in common. They both have a 6 in common. So I can take out a 6 from both terms. You know, it's that Godfather analogy I made with the GCF. And this has 3 m's, or m to the third, and this has m squared, so they both have 2 m's in common. Now, imagine me dividing 6m squared by both of them. And I get a little tired of showing that to students because I say, well, you got to kind of think about it otherwise. Otherwise, you're going to be spending most of your time trying to simplify it. So make sure your factoring skills are up to par. If they are, easy problems. If not, practice your factoring. So if I take out a 6m squared from here, I've got an m left. Subtract. If I take out a 6 from 12, I've got 2 left, and I got no m's. Now somebody might say, well, is that true? 6m squared times m is 6m cubed. 6m squared times negative 2 is negative 12m squared. So that does work. And you divide it by 18m squared. You can't divide two terms by one term. Ain't going to work. But you can divide this one term by this one term right here. So this has m squared, that has m squared. 6 divided by 18 is 1/3. And then I have an m minus 2 left over. And then sometimes students will ask me, do I need 1 and then parentheses m minus 2? You don't need a 1, but I'm not going to mark it wrong. I don't think your teacher would mark it wrong either, but you know. Okay, moving on. Next one, I've got 4a cubed divided by 22a squared. It's one term divided by one term, so it's legal. What does 4 over 22 reduce to? It's 2 over 11. And I have 3 a's in the numerator and I have 2 a's in the denominator. So that means I have an extra one on the top. 2a over 11. Next one. 2c or not 2c. That's a really bad joke. That's one term. That's two terms. I can't factor. It's done. It's actually already solved for. Nothing I can do. So that's simplifying rational expressions. Rewind it. Try it on your own if you'd like to, if it was a little too much, or if I went a little too fast there. If the factoring, though, was a problem, I would look back at factoring. See how to factor properly. And you gotta pick it up. You do, because it never really goes away. And my students are a little wary about that, but we go through the motions, and it actually does get better. But you have to practice your factoring, GCF and all types of other factoring. That said, we're going to do another installment of simplifying rational expressions and see how you do with it. But for right now, have a good day.